next lesson, I'll solve 5 other questions on continuity, finding the continuity. Then I'll start solving the ministerial questions of this topic. Example, discuss the continuity of the function f of x equal 6x minus 2 when x less than 2, 8 plus x when x greater than 2. This function is not continuous at x equal 2 because f of 2 is not defined. Undefined. It is not in the domain of f of x, but we can redefine this function to be continuous as f of x equal to 6x minus 2 when x less than 2, 8 plus x when x greater than 2, k when x equal to. Then we find the value of k by finding the limit of the function when x approach to 2. When x approach to 2 from left, substitute in this segment 6x minus 2 equal to 6 times 2, 12 minus 2 equal 10, and the limit x approach to 2 from right, substitute in this segment 8 plus x equal to 8 plus 2 equal to. Since the limit exists and equal to 10, then I can redefine this function to be continuous by setting 10 when x equal to 2. Discuss the continuity of the function f of x equal to sine x over x plus 2 when x not equal to 0, 3 minus x when x equal 0 at x equal 0. At x equal 0, f of 0 equal to, when x equals 0, 3 minus x, 3 minus 0, sorry, equal to 3. Limit when x approach 0 for this function, substitute in this segment sine x over x plus 2 equal to, since this limit is 1, then the answer is 1 plus 2 equal to 3. Therefore, the value of the function at 0 equal to the limit of the function when x approach to 0, then this function is continuous when x equal at x equal 0, or when x approach to 0. Example, f of x equal tan 2x over x is discontinuous at x equals 0. Redefine it to be continuous at x equals 0. This function is discontinuous because f of 0 is not defined. Tan 0 over 0 is undefined term. Tan 0 is 0 and 0 over 0 is undefined. But we can redefine this function to be continuous by finding the limit when x approach to 0 to f of x tan 2x over x multiply by 2 and divide by 2 equal to, this limit is equal to 1, then 2 times 1 equal to 2. Now redefine this function by set f of x equal to tan 2x over x when x not equal to 0, 2 when x equal to 0. Now f of 2 is 2, the limit also is 2, the function is continuous. Determine the point of discontinuity. Example, determine the points of discontinuity of this function. 3 over square root 7 minus x. 7, the point of discontinuity is the point make 7 minus x less than 0 or 0. So I'll set 7 minus x less than or equal 0, because this point make the root undefined, and also since it is in the denominator, also 0 is undefined term, give me undefined term. Now solve this inequality to find the value of x. 7 less than or equal x greater than or equal 7, it is 7 to positive infinity. This is the interval where the function is discontinuous. Example, determine the point of discontinuity of the function f of x equal to square root x minus 5 over 4. Since the root is in the numerator, then the point of discontinuity is when x minus 5 less than 0, only less, because the numerator, it is doesn't matter if it is 0. So solve this inequality for x less than 5, then negative infinity to 5 open interval is the set of the interval of discontinuity of this function. Ministerial questions of the subject of continuity. Question number 1. Which of the following has a removable continuity at x equal 0? Removable continuity, it means the function has a limit. This function, we solved it before, it has no element when x approach to 0, because when x approach to 0 from left is negative 1 and from right is 1. So this choice is wrong. This function has a limit. If we solve the limit when x approach to 0 for this function, factorize the numerator by x, then it will be x plus 3 over x. Reduce x with x, substitute every x with 0, the limit is 3. Since the limit exists, then this function has a removable discontinuity. For the sign 1 over x, it is, we solved it before, it is oscillating between negative 1 and 1, therefore this function has no limits. If we take value as 2 over pi, 2 over 3 pi, 2 over 5 pi, then we find that the limit or the value or the function oscillating between two fixed numbers, then this function has no limit when x approach to 0. For the last function, if we reduce x with x, then it will be 1 over x squared, and this function has no limit when x approaches 0. The right answer is B. Question number 3. F of x equal 2x squared minus 3x plus 1 over 6x minus 3 is discontinuous at x equal 1/2. Which of the following is redefined function in order to be continuous? We want to redefine this function to be continuous. To find the redefined function, we should find the limit of this function when x approach to 1/2. Limit x approach 1/2 for this function, 2x squared minus 3x plus 1 over 6x plus minus 3. If we multiply 6 by 1/2, it is 3. 3 minus 3, 0. It gives me undefined term. Then I'll try to simplify this function. Factorize the numerator by 3, then it will be 2x minus 1. 2x minus 1. analyze the numerator by experiment. 2x minus 1, x minus 1. 2x squared minus x minus 2x, 3x minus 1 times minus 1 plus 1. 2x minus 1 with 2x minus 1. Substitute every x with 1 half. The answer will be 1 half minus 1 over 3 equal to negative 1 half over 3 equal to negative 1 over 6. Then the right choice is D. Number 4, which has non-removable continuity at x equal negative 1. Non-removable continuity, it means a function with no limit when x approach to negative 1. Let me check the first one. Limit x approach to negative 1 for x plus 1 absolute value over x plus 1. To find this limit, I'll redefine the absolute value as x plus 1 when x greater than or equal negative 1 minus x plus 1 when x less than negative 1. Then limit x approach to negative 1 from right equal to x plus 1 over x plus 1 equal to 1. And limit x approach to negative 1 from left is x plus negative x plus 1 over x plus 1 equal to negative 1. So this function has non-removable continuity. Let me see the second one. Limit x approach to negative 1 for x squared plus 1 over x plus 1. If we substitute every x with the negative 1, then the answer will be 2 over 0 and define. So therefore, this function is also has non-removable continuity. For the third one, limit x approach to negative 1 for x squared minus 1 over x plus 1 equal to limit analyze difference of 2 square over x plus 1 square, reduce x plus 1 with x plus 1, it will be x minus 1 over x plus 1. Substitute every x with negative 1 plus 1, 0. Also, this function has non-removable discontinuity. The right choice is all of them. The function is discontinuous at x equal 1 and non-removable discontinuity at x equal 1. Which of these functions has discontinuity at x equal 1 and non-removable continuity at x equal 1? This function is continuous at 1. So I'll leave it because 1 over 1, the value of f of 1 exists, the limit also exists, so this function is continuous. This function is also continuous because the limit when x approach to 1, analyze difference of 2 square for the numerator, reduce x minus 1 with x minus 1, substitute every x with 1, then the limit is 2. Then also this choice is wrong. For the third one, this function has it is discontinuous at 1 because f of 1 is undefined and the limit is not exist. Limit 1 over x minus 1 when x approach to 1 equal 1 over 0, undefined, the limit does not exist. For the last one, it is continuous because 1 over 1 plus 1 is 1 over 2, and the limit also is 1 over 2, then this function is continuous. The right choice is C. Question number 8, which of the following has non-removable discontinuity at x equal -1? Non-removable discontinuity, it means which of the following has no limit when x approach to -1. Let us solve the first one. Limit x approach -1, x plus 1 square over x plus 1, reduce x plus 1 with x plus 1, then it will be x plus 1 when x approach to -1 equals 0. The limit exists. This function has removability continuous. Let us solve the second one. Limit x approach -1 for x squared minus 2x minus 3 over x plus 1 squared. Limit x approach to -1, analyze by experiment for the numerator. X minus 3 plus 1 over x plus 1 squared. X squared minus 3x plus x minus 2x minus 3. Reduce x plus 1 with x plus 1. The limit will be x approach to -1 for x minus 3 over x plus 1. -1, -3, -4 over -1 plus 1, 0, undefined. Then this function has no limit and no removable discontinuity when x approach to -1. Let us complete this function. Limit x approach -1, analyze difference of 2 square, reduce x1 with x plus 1, substitute every x with -1. The answer is -2. The limit exists and has a removable discontinuity. For this function, substitute directly every x with -1, then -1 plus 1 over -1 minus 1, 0 over -2 equal to 0. The limit exists. The right choice is B. Which of the following has non-removable discontinuity at x equal -2? It is the same of the previous question. Which function has no limit when x approach to -2? When x approach to -2, the first function is x power 2 plus 4 over x plus 2. I cannot analyze the numerator, difference of 2 square, because I have a plus here. Then substitute directly. It is -2 square for 4 plus 4, 8 over 0, undefined. Then this function has a non-removable discontinuity at 0. Also, this function, if we find the limit when x approach to -2 for 2 over x plus 2, then we have 2 over 0, also undefined. Also, this function has a non-removable discontinuity. If we want to find the limit of this function, also I'll find limit when x approach to -2 from left, the answer is -1, and from right is 1. Then the limit is not exist. The right choice is all of them. Question number 11. Which of the following has a removable discontinuity at x equal to? Removable discontinuity, it means which function has a limit when x approaches to 2. This function, we solve it here. It is undefined and has no limit, so it is wrong. For this function, if I find the limit when x approaches to 2 from left, then I substitute in this segment 2 times 2, 4 minus 3 equal 1, and the limit when x approaches to 2 from right, substitute in this segment. The answer is 3 times 4, 12. 12 minus 5 is 7. Also, this function has no limit when x approaches to 2. For this function, also, we solved it before. It is limit when x approaches to 2 from left for f of x equal -1, and limit when x approaches to 2 from right for f of x equal to 1 and the limit not exist. Let us check the last one. Limit when x approaches to 2 for factorized by negative x minus 2 over, x plus 2 over factorized by 6, x plus 2. 6x plus 12, x plus 2 with x plus 2, then the answer is -1 over 6. This function has a limit and a removable discontinuity. Number 12, which is continuous at x equal 1. Continuous, it means the function defined when x equal 1, all these three functions are defined, then I need to find the limit when x approaches to 1 for this function. For the base function, the value of limit when x approaches to 1 to x plus 1 is 2, but the value of the function is 0, therefore this function is not continuous. For the second function, the limit when x approaches to 1, then I substitute in this segment x power 2 minus 1 over x minus 1 equal to limit, analyze difference of 2 square, x minus 1, x plus 1 over x plus 1, reduce x plus 1 with x plus 1, substitute every x with x minus 1 with x minus 1, substitute every x with 1, the answer is 2. And the value of the function when x equal 1 is also 2, then this function is continuous when x equal 1. Let us check the third one. F of x is f of 1 is 0, and the limit when x approaches to 1 for x minus 1 is 1 minus 1 is 0 also. Since the limit is equal to the value of the function when x equal to 1, then also this is true. The right choice is both C and B. Question number 14. Which of the following has removable discontinuity at x equal to? Removable discontinuity, it means which function has a limit when x approaches to 2. For the first one, let us check the limit when x approaches to 2 for this function, factorized by x minus 2, factorized by negative x minus 2 equal to negative x, limit x approaches to 2 to negative x equal to negative 2. Therefore, this function has a removable discontinuity when x approaches to 2. Let us check B, limit x approach to 2 for x power 2 factorized by x plus 2 over x minus 2 equal to limit, substitute every x with 2, then the answer is 2 plus 2, 4 times 2, 8 over 0, and define this function has no limit. Let us check the third one, limit x approach to 2, analyze the numerator difference of 2 square, x minus 2, x plus 2 over x minus 2. Reduce x minus 2 with x minus 2, substitute every x with 2, the answer is 4. Also, this function has a removable discontinuity when x approach to 2 or when x equal 2, then the right answer is both A and C. Number 15, which of the following has removable discontinuity at x equal 2 and non-removable discontinuity at x equal 8? It means the limit exists when x approach to 2 and not exist when x approach to 8. Let us check the first one, limit x approach to 2 for this function. When x approach to 2, 2 square, 4. 4 minus 10 times 2, 4 minus 20, negative 16 plus 16, 0. Therefore, the directly substitution is not work. I must analyze the numerator and denominator by experiment. If it is go, xx 16, it is negative, positive, negative 2 and positive 8. X power 2, 8x minus 2x, 6x, 2 times negative 2 times 8, negative 16. For the denominator, x positive, negative, it means negative, negative 16, negative 2, negative 8, then reduce negative 2 with negative 2, the answer will be limit x approach to x plus 8 over x minus 8. And the answer is 2 plus 8, 10 over 2 minus 8, negative 6. The limit exists and the function has a removable discontinuity and at x equal 2. But if we want to find the limit when x approach to 8, then it will be x plus 8 over x minus 8, and it will be 16 over 0 undefined, and the function has non-removable discontinuity at 8. Therefore, this is the right choice. For this function, if we want to check it, then the limit when x approach to 2 power 2, 4. 4 minus 20, it is not 0. Therefore, I substitute directly every x with 2. The answer is 4 minus 16 minus 12 over 4 minus 20 minus 16. The function has removable discontinuity at 2. At 8 power 2, 64 minus 80, it is also not 0. Therefore, this function has a removable discontinuity at 2 and removable discontinuity at 8. For this function, if we substitute every x with 2, then 4 minus 16, it is not 0. The function has a removable discontinuity. And if we substitute every x with 8, 8 power 2, 64 minus 16, also it's not 0. Also, this function has a removable discontinuity at 8. For the last function, if we substitute every x with 2, 4 minus 20 minus 16 plus 16, 0. Therefore, I should check when x approach to 2, analyze different addition of 2 cube, x plus 2, x power 2, reverse sign, 2x plus 4 over x minus 2, x minus 8, x power 2 minus 10x plus 16. Therefore, this function has no limit when x approach to 2 and has non-removable discontinuity when x approach to 2. Therefore, the right choice is A. Number 16, which is discontinuous at x equal 2. Discontinuous, it means the value of the function when x equal 2 not equal to the limit of the function when x approach to 2. Let us check the first one. Limit when x approach to 2 for 3x squared minus x minus 10 over x minus 2 equal to limit x approach 2. Let us analyze the numerator difference of 2 squared, 3x, x, minus 2 plus 5. Let us check 3x squared, 5x minus 6x minus x minus 10 over x minus 2. Reduce x minus 2 with x minus 2. Substitute every x with 2. 3 times 2, 6, 6, 5. 6 plus 5, 11. This function is continuous at 2. So it is not the right choice. Let us check this function. Limit x approach 2 for this function x minus 2. Analyze difference of 2 cube, x minus 2, x power 2 plus 2x plus 4, x minus 2 with x minus 2. The answer is 1 over 2 square, 4 plus 4 plus 4, 12. This function is discontinuous because the value of the function not equal to the limit of the function. Let us check this function. When x approach to 2 from left is 0, from right is also 0. Therefore, this function is continuous. Let us check this function. When x approach to 2 from left, 2 minus 2, 0. From right, 2 minus 2, 0. Also discontinuous. The right choice is B. Number 17, which has removable discontinuity at x equal 1. Removable discontinuity, it means which function has a limit when x approach to -1. This function has no limit when x approach to -1 because the limit when x approach to -1 from left is -1 and limit when x approaches to 1 from right to negative 1 from right is 1. Therefore, this function has no removable discontinuity. Let us check this function. Limit x minus 1 over x minus 1, x plus 1, analyze difference of 2 square, x minus 1 with x minus 1, x approach to negative 1. The answer is 1 over 0. Also, this function has no limit when x approach to negative 1. Let us check this function. Limit x approach to negative 1, factorize by 2, x plus 1, over analyze addition of 2 square or 2 cube, x plus 1, x power 2 minus x plus 1, x plus 1 with x plus 1. The answer is 2 over negative 1 square 1, negative time negative 1, plus 1, plus 1, 2 over 3. This function has a limit when x approaches to negative 1, so it has a removable discontinuity. Let us check the last one. When x approaches to negative 1 square, 1, 1 minus 2 minus 1 plus 1, 0. Let me check if the numerator and denominator analyzed by experiment. X negative 4 plus 1 over x plus 1 plus 1, x plus 1 with x plus 1. Substitute every x with negative 1, negative 1, negative 1, 4, negative 5 over 0, and define. Then the right choice is C. See you next lesson.